All right, so welcome everyone. We are going to be talking about our solar system today. Everyone's hung in for 9 weeks, and finally in week 10, we get to actually talk about planets. So this is going to be really fun, but hopefully, we've laid a big foundation here, and it's going to be wonderful. Exactly, planetary. So like I said last week, talked about lenses. We talked about different telescope types and how they, hey Benny, we talked about like the different types of telescopes you can get, like what a Cassegrain telescope is, and how you can kind of delineate the two, and why, not all telescopes, you just go out and do that. That you end up looking down a little piece on the side. But that's what that is. And then we talked about the different types of electromagnetic telescopes and how we use them to view our solar system and beyond our solar system, really. Talking about like radio telescopes, gamma ray telescopes, X-ray telescopes, infrared telescopes, all of those fun things, and kind of what the type of thing is that they look for, and then how we can make composite imagery and all that. So you can check out that video from last week if you missed it. But this week, solar system. All right, so it is time. We are going to go through each of the 8 planets, and then I will explain why there's 8 instead of 9, and I promise we'll all be friends at the end of it. And I'm very happy that my moderator's here just in case. Because people are very passionate about space, which I respect and I love and I understand. And hopefully my explanation about why dwarf planets are a thing makes sense, and we can have a good conversation about it that is civil and kind and follow the rules and all that fun stuff. So, hey Todd. All right, so we're gonna start at the sun. Thanks, domestic. Yeah, just make me nervous. I appreciate that. So we're gonna start at the sun. We're gonna work our way out. We're just gonna kind of do bang box fun check, like fun fact type things about it. But after we do that, depending on what time it is, we might discuss a little bit about the patterns of the solar system, but some of that will sort of creep in organically just as we're having this discussion. Talking about which way the planets rotate, the fact that they all lie in this flat plane, that they all orbit in the same direction around the sun. We will learn why that is the case. Maybe not next week, but at least the week after that. Talking about the formation of the solar system and why they are the way they are. And when you start to look at these planets, you can start to pull out patterns and learn these things and almost solve that question backwards by saying, okay, so if they're all doing this, but there's one outlier, what could have happened to have caused that? And so you'll see as we go through the different planets which ones kind of stand out as oddities. But we love them all. So be prepared. At the end, I will ask you about what your favorite planet is. So think about that ahead of time. But first, we're going to talk about the distance scale. Now, normally in Astronomy 101, this is my alma mater at the University of Colorado, we would go for a walk and we would talk about the distance. And we did this a little bit talking about the cosmological address, about how space is very big. That was kind of week 1. Trying to give everyone an existential crisis here. So this is at the University of Colorado in Boulder, but it's also, there's one in Washington, D.C. at the National Mall. If we were going out and exploring these sort of things, this would be a great activity to socially distance do, but none of us are in classrooms right now. So we are going to do this virtually. But if you do ever get a chance to do one of these, it is really fun. You'd think it wouldn't be. I don't know. You guys are here, so you might be inclined to enjoy these things. Hey, Joel. But I think it's fun, and it kind of blows your mind when you are doing these. So you can see here in the triangle thingy one, the big ball bearing there. Oh, awesome, planetary. Yeah, there are lots of these walking scale things. So you see that big brassy type ball, that's the sun. And that's the sun to scale. So that's going to be kind of our reference point. So this is, if the sun were that big, then everything else is going to be scaled to that. So the planets, how far away they are and how big they are all relative to this. So you can see here, we've got some fairly close ones here, but then you end up having to walk like all the way across campus to get all the way out to the outer planets, even though the first ones you start here. But we are going, because we can't do this, because we're not at a campus or we don't have these with us, we have a virtual version of this. So I'm going to try to pull this up really quick. And, yes, it worked. Hi, Uncle Bill. So this is going to be our virtual walk in a solar system. And you can look this up. I will put it in the chat for everyone else. So you can all have a look at that. But this is if the moon were only 1 pixel. And we're going to go. All right. So there's our reference. This is the sun. I promise I'm not going to make us do the whole thing. This is the sun. That's going to be our scale. They started off saying if the moon were 1 pixel on the screen, that's what it would be. So starting from the sun, we're going to start walking. Oh, hey. Yes, Scriptorium. I have seen the Power of 10 video. Also very powerful. Very good. So just now, that was about 10 million kilometers. We're going to keep going, keep going, keep going, keep going. It's pretty empty. You can see why they make the original sun and these physical ones a lot bigger. So here comes our first planet. And there's Mercury. Yay! We found Mercury. Tiny, tiny, tiny dot. That far away from the sun. So the sun was, I don't know, about that big. And then that was the distance to get to just that tiny dot. So we'll keep going a little bit. I don't know, Zach. That's a great question. I just saw your question. How has it been 5 months already? I agree. But thank you. I appreciate it. So things are pretty far apart. I'm reading these out as we're going. Yep. Still. We'll be coming up on a new planet. Sit tight. I love doing these. There's Venus. Yay. A little bit bigger than Mercury. Hooray. That's far. And like I said, I sent you that link. Most of space is just space. You can go do this yourself. I challenge you to make it to Saturn. I mean, I give you the challenge. It can be done. We're halfway to our home. That distance to Earth. Yeah, we made it. Earth. Whoop whoop. So we'll leave it there. You can see the moon is a single pixel there. But yeah, you can check it out. It's definitely super, super fun and awesome. Yeah, you're not, if you choose to accept this challenge, you're not allowed to fall asleep. You have to sit and go through the whole thing. Good luck. 'Cause space is really big. Who'd have thought? Things are very small compared to how big space is. That's pretty, uncommon. Common. No, I haven't Tropical Geek, and, I can't see that link, because, I have links, only myself and mods can post links, but I will check that out. So thank you for sharing that. I appreciate that. So that was, if you can't read it, National Geographic's Guy Build a Massive Solar System in the Desert. Awesome. I love it. Yeah, space is annoyingly very, very big. And this is something that, like we said at the beginning, kind of takes a lot to wrap your mind around. Oh, thank you, Kishore. I appreciate that. I really appreciate it. Okay, so we're going to do this. The sun is very big. It's about 100. Oh, I didn't update the rest of these are all fixed. The sun one isn't. There's always one mistake in these. Yes, it was, Todd. It was about 16 times the speed of light. They throw in all those cool facts there. That's great. So I love it. Definitely check it out. So the radius of the sun is 696,000 kilometers. That means very little to our Earth-centric brains. So we say it's 108 times the radius of the Earth. That should say our Earth. And its mass is 333,000 times the mass of the Earth. Sure, we'll call that warp 1. I like that. We'll call that warp 1. The composition of the sun is mostly hydrogen and helium. It's got some other elements in it, but those elements, so when we talk about solar system and star formation, which we will get to, we'll talk about the fact that a star is a ball of gas, as Pumbaa said, and in the middle, it's fusing hydrogen into helium. Now, as that starts to fuse, it goes through its life, then it'll fuse heavier and heavier elements, then it dies, and those elements are kind of returned to the cosmos, to be picked up by other star-forming regions. So that's how our sun, even though it's in the midst of forming hydrogen into helium, has other elements in it, is those like residual stardust from other stars that have come and gone in the past. So, thank you, Planetary, I appreciate it. And the coolest fact, I think the coolest fact about the sun is that it takes up more than 99.8% of the total mass of the solar system. So if you lay out everything in the solar system, the sun is almost all of it. It's almost all of it. And that's why, I mean, its gravitational presence dictates everything. All the planets, all of the, asteroids, everything goes around the sun. Oh, thank you for the follow. President Poppy, I like it. So that's bonkers. That's crazy. That's a lot. And it's hard to kind of wrap our head around kind of the scale, how big things are. But sun, most massive object in the center of our solar system, and it is 99.8% the mass of the entire solar system. Yeah, Soul's got you waxed. I like that. Okay, I have my reference here, so all the fun facts that I didn't put in, I can remember these as we go. But I think that was pretty much it from the sun. There are some really cool images that have come from thank you, Craig. Cheer. Woo woo. What's the coldest planet in our solar system? That's a great question. So we will talk about Uranus and Neptune, and they're pretty much tied for coldest. And you'll see. Thanks, Scriptorium. Thank you, Craig. Yes, we will get to Neptune particularly, and then talking about planets versus dwarf planets. But the surface, the sort of cloud top temperature of Neptune is 60 Kelvin. And it's kind of the same for Uranus too. They're both around 60 Kelvin. Thanks, Craig. And so that means 60 degrees Celsius above absolute zero. So we use the Kelvin scale, where 0 is like no motion. There's no, particles are not moving at all. They're completely frozen. That's absolute 0. And so this is only 60 degrees Celsius above that. That's where we call Celsius and Kelvin, kind of 1 degree Celsius equals 1 degree Kelvin. So for some of you may be familiar with Celsius a little more comfortable with that. So it's cold. It's very, very cold. But yeah, that's a great question. And the reason it's not totally frozen, as opposed to just the vastness of space, is because it is absorbing some light from the sun. And so that absorbing of the light, the friction, the motion of all of the stuff in the on the planet, all of that is heating it up slightly, but it's still very, very cold. But we'll go from the coldest one to the hottest one, hottest-ish, the close planets. So Mercury. Mercury is the closest planet to the sun. For some of you, you may have seen my space-time talk where we talk about the fact that Mercury precesses. I wasn't doing that very well. Sorry, my mirrored thing. Precesses as it goes around the sun. It's not as extreme as that, but it does trace out a slight flower shape as it goes. Just the nature of its orbit. So it's only 0.39 AU, and that is where 1 AU is our ruler, where sun to Earth. That's 1 AU. So this is just over a third of the distance between the sun and the Earth. I agree, Scriptorium. So it's about a third the distance. It's about a third of the radius. It's not very dense at all. Well, no, it's dense. It's not very massive. It's only 0.05 the mass of the Earth, which is crazy. But composition, rocks, metals, and it has no atmosphere. So the side where the sun is hitting it, that you're seeing here, this is 700 Kelvin during the day, versus 100 Kelvin at night when it's dark. Now, we're not totally used to Kelvin think about around 300. I think like 290, 300. That's kind of Earth range. So this is about twice as hot. Thanks, it's that bean. So this is about twice as hot on the sun side. On the night side, all of that heat just disappears. It goes away. It's only that little residual thermal heat that this planet has, so that heats it up to 100 Kelvin. So that's only 100 degrees above absolute zero. It's still cold. It has no moons. You can kind of see here, this is kind of cool. And next week we'll be talking about the different spacecraft that are exploring our solar system and the types of things that they look for. But I think it was Messenger spacecraft looked at the poles of Mercury, and it found that in these poles, I don't have a picture of it here, sorry, but you can kind of see obviously there's craters everywhere, but there's craters up here at the top. And some of the craters are so deep that the sunlight comes and hits and never makes it into that. You're going to have a crater where in the bottom, it's always dark. It's always dark. You never get sunlight. And actually, in those deep, dark craters, they have found frozen water ice. Ice was around, it's part of our solar system. We find it everywhere. Our planet likes it. It's great. But just because there's water, that's not like a huge surprising thing. We see water throughout our solar system. But the water ice in there stays frozen because it never sees the sunlight. There's no atmosphere. There's no blanket to heat it up or to melt it. So pretty cool stuff. All right, next we'll go to Venus. So Venus is almost 3/4 of the way from the sun to the Earth. It's pretty much the same size, 0.95 times the radius of the Earth. So, 95%. It's about the same size. It's a little less massive, so it's only about 82% the mass of the Earth. Again, rocks, metals. This is a rocky one. It's a proto-molecule approved planet. Thank you. Excellent reference. And its average temperature is actually hotter than Mercury because it has a runaway greenhouse effect here in its atmosphere. And Benny asked the question, didn't Mercury start way further out in the solar system? We don't know. There's lots of interesting theories about Mercury. One of the things here is that these ridges that you see there, I've thrown my Seinfeld reference. There's been some shrinkage. And we'll go into much more detail on these rocky planets here, but they, and because of its density and everything, we think that it's basically the iron core that's left behind. So it's basically shrunk down, and it's possible that it was much bigger, got hit by something, moved closer. All of those fun things are all things that we're piecing back. Yeah. So we have Venus now. Venus has a heavily carbon dioxide atmosphere, so we get this big greenhouse effect, where sunlight comes in, hits, gets radiated back off as infrared radiation. That infrared radiation gets trapped by the atmosphere. So it stays really hot. It stays really, really, really hot. Huge air pressure. It's about 90 times the air pressure on Earth. So here, we're walking around, that air pressure, there's a column of air above us that our bodies are used to. If you add it all up, it adds up to about the weight of a car-ish, but our bodies are used to it. On Venus, it's 90 times that amount of weight, so that would not be good. That would be hard for us to walk around it. And in fact, when they first sent spacecraft, I think the Soviets sent spacecraft to take pictures of the surface of Venus. Again, we'll talk about all of those next week when we talk about exploring the solar system. But as it started to go through the clouds, this spacecraft basically fell through and just went and died with all of that. Yeah, Venera, from the atmosphere being so dense. So that wasn't expected. But I still have my money and my hopes and dreams pinned on building a cloud city in Venus. Would any plants we have here thrive there? That's interesting. I mean, the atmospheric pressure and the temperature are both almost impossible. So you'd have to undo those. You'd have to undo the greenhouse effect. The greenhouse effect. Yeah, was it Venera that was the first one that actually landed? I know the very first one they sent did not make it through. But it might have been Venera that did make it through. Anyway, then we get to Earth. Home. I always love when I ask kids, like, what's your favorite planet? And they're always like, Earth. Because I live here. Valid. So obviously we're scaling everything based on Earth. So it's 1 AU from the sun, because that's how we define an astronomical unit. It's 1 radius of Earth, because it's Earth. It's 1 mass of Earth, because it's Earth. and the average temperature is 290 Kelvin. And it has 1 moon, as we know. And the interesting thing with the moon is that, first of all, it's the first moon that we've come to of these terrestrial planets. But it's, compared to the size of Earth, it's huge. It's huge. It's huge. So there are theories that, something came and hit and then chipped off and then formed the moon. But we'll talk all about that in solar system formation. Thank you, Planetary. Venera 9 and 10 made it. Thank you. Yeah, thanks, Scriptorium. That's what I'm hoping. Because Earth. But we love it. It's that's why I'm here. I want to teach Astronomy 101, so everyone can have access to it. But I can't give you college credit, so sorry about that. But yeah, the moon and the moon formation are fascinating. So we will, when we get into solar system formation, we'll talk in great detail about why the moon looks the way it does, how it possibly formed, and where it came from. All that fun stuff. So, carrying on, we will go to Mars. I think Mars is now actually my favorite planet, because I just get excited when I talk about it. I used to think that it was Saturn, but then I just get so happy every time I get to talk about Mars that when I was putting this together, I was like, I think Mars might be my new favorite planet. But we love Mars. Mars is amazing. So it's 1.5 AU away from the sun, which basically means we have the sun to the Earth, and then it's half that distance extra. So it's 1.5 AU. Yeah, thanks, Blue Burger. I appreciate that. And yeah, Scriptorium, Mars, the graveyard of failed interplanetary spacecraft. You're not wrong. It's very, very, very hard to survive on Mars. It's very tough. Yeah. I find Mars very fascinating. I think it's brilliant. All the rovers, we love all the rovers. They just, some, just buried themselves in, didn't even get a chance to land. And yeah, we'd love to go there, enlist in the, Marines, whatever, expanse stuff. God, I'm not on top of things today. But okay, little facts about Mars. So average distance from the sun, I said about 1.5 AU. It's about half the size of Earth. So it's about half the radius. You have Earth, it's about half the size. Its mass is only about 10%, 11%, which means that the gravity on there is about a third. So it's about a third. And yeah, space is hard and scary and dark. The average temperature is about 220 Kelvin. It does have an atmosphere, but it's only 0.6% of what it is here on Earth. So 0.006 times what Earth's atmosphere is. Yeah. And it does have 2 moons. It has Phobos and Deimos. They're little potato-shaped moons. Very, very, very tiny. Probably captured objects at some point. So they are... because they just kind of randomly go around and they're super tiny. Yeah, all right. Good luck with that, Scriptorium. I appreciate that. Yes, and if you are interested, I will post this to when it's on. So if you're watching this on YouTube, follow that link. But you're watching it live. I don't have that magic to do that, but you can catch my episode club episode where we talk about the science behind the Martian, and the link to my YouTube channel is actually down there, so you can check those out. And Princess of Mars, yeah, is brilliant. I love all the pictures. Anytime like I'm really down, looking at pictures of the surface of Mars and rover selfies, I will say, is probably my favorite thing. But really interesting stuff. We will go all into the history of, we could spend an entire lecture talking about Mars. But interesting just to note here, where we have, and Daib mentioned Olympus Mons. So over here we have these volcanoes. I also recommend the Futurama episode where they're on Mars for the first time with Olympus Mons. That's a big volcano. Where is it? So yeah, Mariner Valley here now, or Valles Marineris. This is this big crack, and it kind of looks like the Grand Canyon. So as Planetary kind of mentioned, there was a thought that this was evidence for liquid water, that this was like the Grand Canyon, and the Grand Canyon, was formed from erosion from a river. Since being able to further study it and further analyze it, we now know that this is not caused by erosion. There are some really interesting theories about where this came from. Probably my favorite theory is that it was an impact crater on the other side, because there's a massive crater on the other side. And then you get all of the volcanoes over there too. So really fascinating. Like I said, we could spend an entire lecture course on Mars, and we probably will. Okay, so moving out into the gas giants. So in between here, yeah, the old Cosmos show for sure. And yeah, poor Percival Lowell. He was the one who did he discover Mars? No, he discovered Pluto. Which was Percival Lowell? My history, not a historian. Damn it. I'm a astrophysicist, not a historian. That's right. Thank you. I knew that. So between Mars and Jupiter, there's an asteroid belt. We have these asteroids. They're lumpy rocks. They're this big sort of path between Mars and Jupiter that's filled with these asteroids. Some, lots of theories, like, was it thank you, Planetary. Was it a failed planet, or was this all just like stuff that was sort of pulled towards Jupiter versus the inner solar system? Lots of interesting theories about this. Now, Jupiter, we sometimes, refer to it as the bodyguard of the solar system, or the bully of the solar system. But just a few facts about it first. It's just over 5 AU, so 5.2 AU. So 5 times the distance between the sun and the Earth. It's 11 times Earth's radius. It's over 300 times Earth's mass. It's hydrogen and helium. And the cloud top temperature is 125 degree Kelvin. Now, I did put in here moons at least 79. So the reason that I did it that way is because we talk about moons versus satellites. Satellites being not artificial, but just loose rocks, that are floating around there, and like, how big do they have to be to become moons? But with Saturn, which we'll get to, when Cassini went around Saturn, they saw hundreds of these satellites and moons. And so Jupiter now has a spacecraft that got there, 3 years ago now? 4 years ago? 4 years ago. Did Juno get 4 years ago? That's not right. When did Juno get to Jupiter? Did it end? I think it entered orbit 4 years. Geez, 4 years ago. I'm sorry, my brain just fried. Because it's there, it's like Cassini. It's going to keep seeing more and more and more stuff. And so even though we only have 79 now, there could be more. And typically we'll say okay, these are the amount of named moons versus the amount of actual stuff that's floating around it. There can be a distinction there because some of them are just super tiny and hard to tell apart. And thank you for the details, Scriptorium. Sorry I forgot all that about Percival Lowell. I appreciate that. Yeah, July 2016. What? What is time? Why? I literally could have told you that was yesterday. That feels like it was yesterday, but it was a lifetime ago. Jeez, oh man. I remember, the reason I remembered it was 4 years ago before my brain broke was it was, first of all, a totally different part of my life, but I remember watching The Arrival, and it was July 4th, and everyone was firing fireworks outside, and I was just, as everyone was celebrating the successful arrival at Jupiter, and I was like, everyone's just celebrating space. I completely co-opted all of the fireworks celebration to be about Juno. But it was amazing. Yeah, Benny. Yeah, I do. All right. Oh, that's really cool, Scriptorium, for sure. All right, so Jupiter. I talked a little bit about Saturn briefly. We have many, many, many amazing, amazing pictures of Saturn thanks to the Cassini mission. Rest in peace, Cassini. We love you. Saturn is about 10 times. So these distances are getting further. They're, this is far now. Jupiter was just over 5.2 AU. This is now almost 10. So we kind of tend to lump them together, but just it's almost double the distance. So Saturn, this is why I said challenge to get to Saturn. Now, planetary, that is a good fact. All the moons are named after Jupiter's lovers, and NASA sent a spacecraft named Juno, which is Jupiter's wife, to go check in on them. That's really good. So yeah, Saturn's about 10 times the distance from the Earth to the Sun, away from the Sun. It's about 9.4 times the radius of the Earth, and it's about 95 times. Now, the fact everyone knows is that its density is less than 1, so if you put it in a bathtub, it would float, which I love. And it's, like, not super accurate, but it's a very not dense for that, I think. Now, yeah, it has about 82 moons, but, I mean, we technically have hundreds. There's like over 60, I think, named moons, and then a few dozen that are still being confirmed. And then we've seen just tons of satellites, like just little rocks that are floating around it. Yeah, that's really fabulous. Lots of interesting theories that we'll get to when we talk more about Saturn and its moons, about these rings. The fact that you might have heard the rings are disappearing, or what's happening with the rings. So they're made up of ice and rocks. If you were to actually go to the rings, they would be rocks and dust and ice. They're not solid, and they have these gaps in them due to sort of slightly larger objects that are gravitationally separating these rocks and rings. But we do know that Saturn's moon Titan has basically has geysers on it, and it spits up liquid water. And is this Titan? No, I'm sorry, that's Neptune. Enceladus is Saturn's moon. So Enceladus spits up water that then immediately freezes and gets pulled into the gravitational pull of Saturn. So that kind of replenishes the rings and makes them bright and shiny and pretty, and yeah, pretty cool. Looking forward to talking more about Saturn. That was my favorite before Mars won. All right, any other fun facts about this one? Okay, so we'll talk about Uranus. This is kind of a composite image of Uranus because I wanted to show clearly that it's on its side. If you look up a picture of Uranus, it's also it's a little bit lighter than this, and it's more smooth. You don't actually see rings in the visible spectrum. You don't see rings. You don't see these bands in the visible spectrum. It really just looks like a gray ball. Yes, Craig, thank you. Good fact. 63 Earths can fit inside Uranus. It's about 20 times the distance between the sun. It's about 20 times the distance between the sun and the Earth, about 19.2 AU. 4 times the radius of the Earth, 15 times the mass of the Earth, and hydrogen, helium, and then these hydrogen compounds are what make it blue. So water, ammonia, and methane are kind of what make it the blue color. And then, as we mentioned at the beginning, thanks to Craig's question, the cloud top temperature is about 60 degrees Kelvin. It has at least 27 moons, but it's on its side. And that's the interesting part about Uranus, is that it orbits like that, and all the other ones orbit or spin like this. Uranus spins like this, and so there's theories that something ran into it and then tipped it on its side early in the formation. And again, we'll get more to that too. Yes, Craig, thank you. Excellent fact. First planet discovered via a telescope, which is really cool. All the other ones we can actually see with the naked eye, as we know. Andrew, always the butt of bad jokes. Brilliant. And yep, the the moons are named for Shakespeare characters. You guys are killing it. This is awesome. All the best facts. I appreciate this. So now Neptune. We have Uranus. Now we have Neptune. Also blue. Also heavy hydrogen compounds. And again, even though it's about 10 AU further, it's about the same cloud top temperature because of what it's made of, and like I said, the motion of it just being a gas giant heats it up internally. So it's about so you have about 60 degrees Kelvin out on the surface. It has about 13 moons. One of them, as we mentioned, we have Triton is one of Neptune's moons, and Triton is really interesting. It has let me see if I have this written down. Yeah, we love Triton. So it's the only large moon in the solar system that orbits backwards. And then it also has basically slush fields of slightly liquidy nitrogen. Fun fact. And it was discovered by math. And yeah, it's really cool. And Uranus and Neptune have only been visited by the Voyager 2 spacecraft for now. And we have the Great Dark Spot. And, yeah. All right. Are we ready for this? We're ready for this. Pluto. Pluto is a dwarf planet. We'll talk about why it's a dwarf planet. But I do have to give credit. We love Pluto. We love Pluto. Just because it's a dwarf planet doesn't mean we don't love it. You're entitled to how you feel, your feelings about Pluto. It does have a heart. However, I will show you what I see when I look at Pluto. Now, I'll get into the history of the whole dwarf planet thing and all of that fun stuff, but this is an amazing picture. New Horizons, like I said, it loves us back. It just wants to be loved. That's what's broken everyone's heart. Oh yes, Arcane, thank you. So Venus orbits vertically like this, but it goes in the opposite direction, very, very slowly. So yes, likely from a impact collision. So when I see Pluto, you're never gonna unsee this. That's what I see. It's Pluto the dog is on there. It's too perfect. It's Pluto the dog. I love it. Okay, so and Planetary asked a good question about about it being a binary dwarf planet or all of these things. Yeah, there's a lot of emotion around it, but essentially what happened, this is where I slightly duck under. We discovered Eris. So Pluto was discovered a long time ago. Not in a galaxy far away. It was discovered a long time ago. And the reason that we were able to discover it before versus any of the other ones is because it has a lot of ice on the surface. So it's highly reflective. Because of that, it reflected sunlight more than any other objects in the Kuiper Belt, which made us able to detect it. Since then, our telescopes have improved, and we started to see a lot of other objects. And then we discovered this object, Eris. Yes, as Planetary mentioned, it was discovered in 2005, and it's named after the goddess of chaos and discontent and discord, because everyone went, uh-oh. We knew that Pluto was in, like, a member of this Kuiper Belt. We had started to see these other objects before Eris. Oh, thanks, Arcane. I appreciate it. So we'd started to see other Kuiper Belt objects. So we knew Pluto wasn't alone in its orbit, but this was the first one where we found it Pluto's size. And we were like, uh-oh, okay, there's a lot more. And then we kept discovering Kuiper Belt objects that are not insignificant. So we learned something new. This is the thing that I always like to say when it comes to the dwarf planets. Being a scientist inherently means you have to have an open mind. It just does. You learn things. You have evidence-based. being an astronomer is one of the hardest fields of science because you can't replicate your experiments in a lab. You can make observations, and sometimes your observations are one-off. It happens, it goes away, and then you have to hope you have data and go back and figure out what happened. But other times you observe space, and you can only learn what is given to you. And so because of that, as an astronomer, you have to have an incredibly open mind, because the universe is just throwing stuff at you, and you hope you get something that makes sense, and you piece it together with physics that we know, and you build models, and you try to explain the behavior. But you have to have an open mind because we keep learning new things, and that's exactly what happened here. We started to learn about the Kuiper Belt. We started to realize that there are lots of objects out there that look a lot like Pluto, and Pluto doesn't share that behavior with the other planets. And I mean, it kind of makes sense, right? Like if you're, and we'll go into more detail on the, patterns in the solar system later, but when you think about it, you have these inner rocky planets, these big rocky planets closer to the sun. Then you have a belt of objects. Then you have these gas giants. Then you have another belt. And it didn't quite make sense to have you have a planet within this belt, but there's also other ones. Oh no, don't worry, I'm gonna get to Ceres too. Because then we have this asteroid belt here that looks similar to the Kuiper Belt, and there are large objects in there too. So we can't just say it's because it's round, right? Because there's other round objects out there. We can't say it's just because of its size, because there's other objects that are its size or comparable. We can't say it's just because it has moons, because even though Pluto has a companion named Charon or Charon, I learned at Charon, I can't not, so it's Charon. Pluto and Charon, we always called Charon Pluto's moon, and you can see these other moons that are out here. So the question was well, but it has a system of moons, so does that make it a planet? Well, it doesn't have a moon in the same way, because if you have Pluto and Charon, they orbit each other. They don't you don't have Pluto, you don't have Charon just orbiting it. They orbit each other. The way to think about it is if you were to put them on a scale, the scale balance is going to fall somewhere between them, that they have their gravitational, differences, the gravitational equilibrium. That was the word. Their gravitational equilibrium, thank you, center of mass, is outside of the surface of these other planets, of these other companions. Whereas with the planets and their moons, if you put even Earth and the moon on a scale, the gravitational equilibrium is going to be under Earth's surface. It's going to be on the Earth, or within the Earth. And so that was sort of an issue as well, to try to think about Pluto, because it's not really a moon. They're like companion objects, but we don't call Charon a planet. We call Pluto a planet. So all of these things caused people to kind of reflect, and I mean, that's a big shift. I think as I didn't catch who mentioned that, sorry. Who said, because I learned the planets that way. Andrew Lightstar, yeah. Who said, it's just, that's how I learned them. This is one of the first things you learn when you're a kid, is the, list of planets, and now you're telling me that it's not true. And it's because of science. That's just how science works, and it's hard. It's really, really tough. So I get it. I get the emotional side of it, but then at the same time, we're just learning new things, and that's sometimes what has to happen. So we do have some awesome dwarf planets that are out there. So the definition of dwarf planet then that they came up with to find this happy place is essentially, it has to be big enough to be spherical, round, under its own weight. So it has to be massive enough to be roundish, like an asteroid necessarily isn't, because it's potato shaped. It's just not massive enough to be spherical. So it has to be spherical. But then it hasn't cleared out its own orbit. So the fact that as objects move through their orbits around the sun, their gravitational presence is big enough that they attract objects to it. They clear out their path. Pluto hasn't done that. The other objects in the asteroid belt and the Kuiper belt haven't done that because they're not massive enough. So that's where we call them dwarf planets. And there's some other nuances, but those are really the big things. They have to be big enough to be round, not big enough that they don't clear out their orbit. So with that, there are some cool dwarf planets out there. Personally, I love the name Eris just because of what it gave. Pluto is still adorable, is always going to be adorable, and is allowed to be your favorite dwarf planet. It can also be your favorite object in the solar system, or planetoid, or whatever you want to call it. But it is a dwarf planet. My personal favorite is Ceres. Ceres is a dwarf planet because of this classification. It's a dwarf planet that is within the asteroid belt. So it's between Mars and Jupiter. It was visited by the Dawn spacecraft, got these cool images on it that everyone went, what? Because you started to see these bright parts here. And actually, this is super cool. These bright parts are like highly reflective. You start to see the light continue to be reflected even when it starts to get into shadow. Like right there. Yeah, love it. Broke everyone's brains. I'm like, alien civilization. And then my science part of my brain is like, calm down. But really, really, really interesting. We think that it might be some sort of salt compounds that are just highly reflective that we haven't really necessarily seen before. And yeah, and I'll talk about that whole Planet 9 as well. And honeycomb, that was to placate people. I guess it's a dwarf planet. It's fine. Everyone wants an alien civilization. For me, I also just want this to be a mass relay from Mass Effect. But so we'll get into the Q&A now. I'm gonna stop the recording. Next week we'll talk about patterns in our solar system and exploration of our solar system. So all the different spacecraft that we've sent out and the cool things that we've learned. There's going to be a lot of projecting onto adorable rovers. So, so with that, if you're watching this recording after the fact on YouTube, thank you for watching. Like and subscribe and do all that fun stuff. And you can catch us live at 1 p.m. Pacific time on Fridays on Twitch, which is in the links down below. So thank you again, and we'll catch you next time.